Yeah, to understand the Mohr circle in detail, let us solve one numerical example. So in this numerical example, so this is a two-dimensional stressed element subjected to two normal stresses. So 40 MPa tensile, 30 MPa tensile, and the shear stress 40 MPa. So aim is like this. So given this, in this stressed element, we need to find out the direction, magnitude and direction of the principal stresses. That is, we have to find out sigma 1, magnitude is sigma 1, and you have to find out sigma 2, this is the magnitude, and direction. So direction is tan 2 theta. We have to find out tan 2 theta, that is the first one. Second one, direction and magnitude of the shear stress. So you have to find out tau max. Okay, so direction of this we will see later. Now for this problem, so how do we solve? So to solve this problem by a graphical method we are solving. So by graphical method means the Mohr circle diagram method. So to solve it by Mohr circle diagram, you need to identify the coordinates of the Mohr circle. So as already discussed in the previous lecture, so this face is considered as the x face and this face is considered as y face. So your aim is to just write the coordinates of the x face. So where do we write? So let us write here. So if I write here, so x is equal to, in the form of sigma x tau xy, x comma format. So this is x, this is y. So this is 40 plus 40 because it is a positive normal stress. And what is the sign convention of this? See, this is the shear stress acting in the counterclockwise direction. Counter means, please recall the sign convention which I told earlier. Counter means below. So it's supposed to be minus 40. Okay. Now come to the y phase. So in the y phase, this is y phase. In the y phase, again in the form of x comma y or sigma comma tau xy format. So this is sigma and this is tau xy. So what is the sign convention for the sigma? It is a tensile stress. So it is positive plus 30. And other one will be obviously positive. So don't need to cross check it. So straight away we can write plus 30 comma plus how much? 40. So just locate these coordinates in a rectangular Cartesian coordinate system. So Cartesian coordinate system means you have to draw this on a graph sheet. So take the graph sheet. In the graph sheet, you locate the axis like this. So you know what is this? This is sigma axis. Sorry. This is not sigma. This is tau axis. This is tau. This is sigma axis. This is plus sigma, and this is minus sigma, and this is plus tau, and this is minus tau. Okay. So divide, mark the coordinates, mark the points. So in graph sheet you can directly mark. Make sure this scale and this scale is equal. Okay, so you have to mark you have marked, but what is the scale you take? Scale is very important. What is the scale? See, this 40 MPa stress you are representing on a linear scale. So you require scale. So how much we take? Say for example, let us say 10 MPa is equal to 1 centimeter. So this is the scale I am taking. So you can change it. So 10 MPa is equal to 1 for both x and y. That is very important. So you cannot change the scale for x axis and y axis. So for both it is same. So to represent the x coordinate, x 40 and y minus 40. You know this is x, sigma means x axis, tau means y axis. So 40, so 1 centimeter I have taken 10 MPa, 10, 20, 30, 40. Here also 40, but in the negative minus 40. So minus 40 will come here. So 10, 20, 30, 40. So take this 10, 20, 30, 40. So which is this point? This is point x. This is point x. Now you have to locate point y. So how do you locate point y? 33 units along x direction and 4 units along y direction. So both are positive. Both are positive means that will come in the first quadrant. So So x 30, 10, 20, 30 and y 40, 10, 20, 30, 40. So we write 30, 10, 20, 30, 40. This intersection. So which is this point? This point is y. Okay. Now join x to y by a straight line. Okay, you have just joined x to y. Now the intersection of this diameter with the sigma axis is what is considered as the point C, the center of a Mohr circle, and this is the origin. Taking this point C as center, Cy or Cx as radius, you draw the circle. Take this point as center and draw the circle. So we don't know where it exactly intersect because I have not taken this to the scale. If you draw exactly to the scale, you will get the exact circle and exact intersection. So this is an arbitrary representation. So approximately in this diagram, this point gives you point A and this point gives point B, means this is the maximum principal stress and this is the minimum principal stress. Remember, the direction of maximum principal stress and minimum principal stress are separated by 180 degree. So the sigma 1 and sigma 2 are in straight line, that means 180 degree in terms of 2 theta. So in terms of theta, there will be 90 degree. Now that is what is sigma 1 and sigma 2. Then where is tau, that is the maximum shear stress. From the center C, you draw a vertical line. Okay. So this is what is tau max. Tau max. So let this point be D. Okay. Now to measure the distances, directly you can straight away you can measure. Say sigma 1 is equal to, what is sigma 1? Is the maximum principal stress. It is from O to A. So O to A. You take any linear scale and just measure it directly, that's all, no need of conventional thing. So if it is, for example, 10, 20, 30, 40, 50, 60, 70, around 72 mP. So this is not exact solution, approximate solution. If you do it on a graph sheet, exact solutions you will get. So approximately with respect to this diagram, it is around 72 mP. Then what is the minimum principal stress? Minimum principal stress is here. So in this diagram, so this intersection is taking place in the negative axis. So this would be approximately -2 or approximately, so it is -2 or -3 MPa. So sigma 2 will be the distance O to B. It is O to B. So if this B is taken, if the B point is in the negative side, this axis, then it will be negative. If this point B is right hand side of O, then this will be positive. So because it is an approximated circle, so with respect to this diagram, it will be, so I will write approximately. So this will be approximately say -3 mP. So we could measure sigma 1, sigma 2. Then how do you measure tau max? See, tau max is directly the radius of a Mohr circle. So straight away measure the radius of a Mohr circle anywhere in the diagram, and that gives you the stress directly. So we could able to measure sigma 1, sigma 2 and tau max, that is magnitude of sigma 1, sigma 2, tau max we have determined. Then what is the direction of you have to find? So to find the direction, analytically we use this equation, tan 2 theta is equal to 2 times of tau xy divided by sigma x minus sigma y. But practically, graphically, so we can straight away measure the inclination of the Cx with respect to, see the point Cx, if you project this, see x is in the this side, say fourth quadrant. So angle 2 theta will be this. So how do we take the direction? In which direction? If you rotate the plane x, that will merge with sigma axis. So that is the angle. That means here, from here to here is the angle 2 theta, and direction will be in the same direction how we are rotating. So approximately you will get say 85 around. So this is around. So what you are measuring is directly the angle say 88 degree. So what I have measured is just approximately based on this diagram I am giving you the answer. So in the graphical in the graph sheet directly measure this angle using protractor. So that gives you directly the angle. Okay, then while showing the stresses, direction of all these stresses, you have to show them in an element. So to show the element, show the stresses and directions on an element, you construct an element. First you draw the axis. This is the plane of sigma x. This is the plane, not the direction. Plane of sigma x. This is the plane of sigma y. You have to just locate these points, sigma 1, sigma 2 and sigma 3 you have to locate. Now what is the direction of the maximum principal stress with respect to the plane of sigma x? So this is what is representing plane of sigma x. So that is around 88 degree. In which direction? In the counterclockwise direction. That means from the plane of sigma x, you have to mark 88 degree in the same direction how you measured the angle. This is plane of sigma x. So 88 degree will come approximately here. See somewhere here. It is 88 degree. It will be close to this. Say approximately like this. Okay, so what is this? This is the plane of sigma 1. This angle. This is around 88 degree. In this plane, the maximum principal stresses will exist. The minimum principal stresses will be perpendicular to it. This is 90 degree. Minimum principal stresses will be perpendicular to it. And shear stress will be 45 degree to both of this. So this is 45 degree. This is 90 degree. And your stresses will be like this. This is sigma 1 because sigma 1 was positive. So if sigma 1 is negative, so this direction will reverse. So in this diagram, in my diagram, I got minus 3 mP. So you know sigma 1 and sigma 2 are separated by 90 degrees. So that is why this plane and this plane is 90 degree. So assuming this is negative, the direction of sigma 2 will be towards the plane like this. This is minus 3. So if you have got a positive value, this direction will reverse. Okay. So instead of writing minus 3, I'll just write sigma 2. You write how much exactly you got. And the shear stress will be acting in this plane. So this is shear stress. Okay. This is what is 2 theta. Here you got 2 theta is equal to 88 degree, but here it is not supposed to be 88 degree. It is because so the angles measured in the Mohr circle diagram will be in terms of 2 theta, but this supposed to be in terms of theta. So this not 88 is supposed to be half of that because it is theta by 2. This is then 44 degree. This is 44 degree from this. Oh, this I think.